right, guys, I'm going back to video notes simply because these are relatively a little more easy, okay, and you're more familiar with similarity. This whole unit is on similarity. Similarity is represented in geometry or math like this. It's like the enye in Spanish, similarity. So we could say that two triangles are similar if they have all the same angles. Just a sec. I want to show you this real quick. I want to show you this just real. This is why we study congruence of triangles before we head into anything else. Check this out. If this is a right triangle, I want you to appreciate this. Look, if I draw a parallel line here, to these two lines are parallel. Okay, check this out. This is 90, and they share this angle. So can you see that the third angle is going to be the same? This is 90 plus that angle plus the third angle. This is 90 plus that angle plus the third angle for the bigger triangle, right? So there's two triangles here, correct? These two triangles are similar. Similarity means same proportions. I think that's the easiest way to think of it. Same proportions. In other words, if I call this A and this B, okay, and I call the little one C, and then I call the large one D, E, and the large one F, right? So C is just for the little guy. Maybe I should put that in a different color. Okay, so C is for the green, okay? B is for the green, and A is for the green. It's just really easy to see with a right triangle how similar triangles have the same shape, okay? Different sizes, same shape, same proportions. This is like when you grab a photo on any program and you grab the corner and you enlarge it, and it enlarges it to a similar shape, size, everything, but just larger. Okay, that's similarity. So what this means is that A is to D. Okay, this over this is the same thing as B over C is equal to C over F. What it means is that if you have, what's cool about this is that if you have any like three relationships, or at least knowing that they're similar, you can figure out all the rest of the sides given just a very small amount of information. Okay, so that's where we're headed with this. We're talking about proportions and similarities. So we're going to start with just simple ratios because everything in similarity has to do with ratios. So you got to get really comfortable with them. Okay. It says write the following ratios using two other notations. Well, the first way to write a ratio is to use the word two, 8 to 9. There are 8 girls to 9 boys. There are 8 cakes to 9 pies. There are 8 rocks to 9 diamonds. I don't know. Okay. The first one we would do is 8 to 9 with a colon. Okay. The second notation is 8 to 9. And it's that simple. All of these mean the same thing. Okay. We're comparing 8 to 9, 8 to 9, 8 to 9. Okay. I didn't do 2 examples because I didn't figure that you needed it for this one. Okay. Let's go ahead and go to the second problem. It says writing ratios for real world equations, situations. Okay. There are 3 new books and 8 used books on the shelf. So here's what I want you to pay attention to. Words. Words are important. The word to is going to give you the colon or the division symbol. Okay, that's what's really important. Okay, and when they say ratio, that's the R word for the F word. It's basically a fraction. Okay, so I'm not sure which way they want you to put these answers, but if there are 3 new books and 8 used books, here we are. What is the ratio of all books to new books? Okay, I want you to pay attention to this. Words matter. All books to new books. Whatever comes before the word to is on the top. So we would do all books, number of all books, over number of new books. That's how we do it, okay? The 2 out the whatever comes after the 2 is on the bottom, whatever comes before is on the top. So all books, there's 11 books total, because 3 plus 8 is 11, to new books, or 11 to 3. I'm not sure which way they want it. Okay. What is the ratio of used books to all books? Okay. There are 8 used books, all books, 8 books, all books. Okay. Again, I didn't do 2 because this is basically a lot of these, half of you already done with these. Okay. So let's go ahead and move on. It says simplifying a ratio of whole numbers, problem type 1. All right, so the main thing you're going to be doing is knowing how to reduce, okay? Write the ratio as a fraction in simplest form. I've been working with you on this since the beginning with whole numbers. In other words, we're not going to decimals. So you're going to go 42 over 18. 18 goes on the bottom because it follows the word 2. Now you're looking for common factors. I don't know if you guys know this, but if you add the integers, 4 plus 2, and you get 6, and that's divisible by 3, it's divisible by 3. I don't know if you know that. So like, look, 191, if I add those together, that equals 11. 11 is not divisible by 3, so that's not divisible by 3. But if I were to do 192, that's 12. 12 is divisible by 3, so 192 is divisible by 3. It's a cute little trick. I don't know if you know it already. Obviously, if it's even, it's divisible by 2. So if some of you might be like, I can do 2 really easy. So divide by 2. In other words, 42 is 2 times 21. 18 is 2 times 9. The 2's cancel out and you get 21 over 9. There's still a common factor. We're not done yet. 3 goes into 21 and 3 goes into 9 3 times. So the final answer is 7/3. Okay, then you can do that with any 2 numbers. Like if you had 10 over, 70, that would simply be 10 is the common factor. 7 times 10, 10 cancels, and you get 1/7. The point is to simply keep dividing until you can't divide anymore. Okay. And you might need a calculator to double check whether or not, there's certain factors. By the way, see how we factored out a 2 and then we factored out a 3? That tells you that we could have factored out a 6. In other words, 42, if we know our multiplications really well, we would know that 42 is 6 times 7 and 18 is 6 times 3. And look, you could get there in one step. So it's kind of up to you. Like, I guess it just depends on your multiplication skills. I tend to do this, believe it or not, even though my multiplication skills are pretty good. I tend to always just take it down in pieces. Okay, simplifying the ratio of a decimal. This one is probably not as obvious to you guys. It says write the ratio as a fraction in simplest form with whole numbers. In other words, what's wrong with this one? The thing that is wrong with this one is that it has a decimal. So we have to get rid of the decimal. So what do? Think money. Okay, we want to change from dollars to cents. Okay, we got to multiply. This is a tens places. So we're going to multiply this by 10 in order to get to 72. But you can't just multiply the denominator by 10. You have to multiply the numerator by 10 as well. That is the fraction in simplest forms with whole numbers. Okay. Actually, that's not. For some, yeah. For some reason, they did not. Okay, whatever. Let's just reduce this. What goes into both 40 and 72? Okay, let's do 2. 20 over 36. Okay, equals 10 over 18, right? Equals 5 over 9. Isn't that crazy, you guys? You multiply both of these by 10, and then you end up getting a ratio. But here's the thing. If you could tell they're the same, let me show you, okay? If I were to take a calculator, okay, let me just find a calculator, random calculator. Okay. Okay, and I were to do 4 divided by, what was it, 4 divided by 7.2? Whoa, I didn't do that. I did not do that, y'all. 4 divided by 7.2 equals 0.555555, right? Okay, what if I were to take my final answer, which was 5? Let me clear this. My final answer was 5 divided by 9. 0.555555, right? They're the same thing. Okay, so it's just changing the way that it looks. All right, so if they gave you, I don't know, I'm going to make one up so we can run through this again. Okay, what if they gave you 3 over 2.5? Okay, in some ways now, I could, like this one, I multiplied by 10 because I just wanted to move the decimal over. Okay, it was, in this one, it might be easier for you to think about multiplying by 2 because 2.5, 250 by 2 is $5. So we could just multiply both this, the numerator and denominator, by 2. And you would get 6 over 5. And that would be the answer. But let's just say you didn't know that. 3 over 2.5. And you just decided to multiply both of these by 10. Okay? You would get 30 over 25. And then you would keep going and reduce it. 30 and 25 are both divisible by 5. Do you see how flexible this is? As long as you're doing the math correct, you have a lot of ways to get through this and get to it. Okay? Just wanted to give you a few options there. All right, now we get to the nitty-gritty of solving proportions. Okay? So proportions are solved by cross-multiplying. Oh, you guys have no idea how stressful saying cross-multiplying is for me. And the reason why is because once kids learn cross-multiply, they use it for everything like this. 2/3 plus 1/2. Then you cross multiply. No, you don't. No, you don't cross multiply there. They just use it everywhere. So don't do that. Ooh, I need to lock this down. Lock it. Okay, here we go. So in this, we are going to cross multiply because really all it is, you remember if you want to get rid of the denominator, you multiply by the least common denominator. That's basically what we are doing with this. Okay, it's just a fast way. So you do cross multiply. We get 9w equals 36, and then you divide by 9. And you get w equals 4. And it's that simple. Just to show you, for those of you that are heading into a little bit more advanced math thinking here, what is the least common denominator between 9 and 12? Okay, if you know it, you want to get rid of it, you know it's 36. 9 goes into 36 and 12 goes into 36, right? Okay. Did I do that right? 9 times 36. 9 goes into 36 4 times, yes? Okay, yes. Okay. So you'd multiply it by the least common denominator. And then 12 goes into 36 3 times. 9 goes into 36 4 times. And then you get 3w equals 12, w equals 4. I just want to show you that you could still just think, hey, I don't like fractions. I'm going to multiply by the least common denominator. I don't want you to lose that by cross-multiplying. Cross-multiplying is the fastest way to the end. You guys, it really is. It's quick. I just don't want you to lose why it actually works. And that's really because you're multiplying by the least common denominator. Okay? Whether you realize it or not. All right, so here we go. We're going to cross-multiply again. 5 times 12 is 60. And then you write 6 times x plus 6. Now this is now just an algebra problem from here on out because they like to groom you in your algebra problems. Subtract 36 from both sides. Draw a line because we're not lazy. That's for 24. X is equal to 4. 26 times 4 is 24. All right. So you could do it with variables. It's nice. You just even variables that you have to distribute out. Okay. So they're going to give you like increasingly more quote unquote difficult problems, but they're basically the same, you guys. It's all the same principle. And it doesn't matter which side you do which. Like, in other words, I can put 20 equals 6 times w minus 2, or I could have put 6 times w minus 2 equals 20. No, there's no right or wrong. There's either one is fine. Okay. I probably would do it this way because the w is on the left-hand side, and that's how I prefer to work. Yes, just distribute. I'm not teaching this because you guys should know this. Add 12 to 20, and I get 32. Okay, now look. When I divide by 6, it doesn't go in there. 6 does not go into 32, but they are both divisible by 2. 32 is 2 times 16, and 6 is, of course, 2 times 3. That cancels, and you get 16 thirds. Do you need to go through this step? No, you do not. Of course, you can jump to this step. Of course, I encourage it. Okay? I almost said questions. I forgot that I was doing this on tape. Okay, let's try this one. Poiple, I'll go with Poiple. Now notice this has variables on both sides, but the main thing is that you need to realize is that you have a proportion. Okay, a proportion is when you have two fractions equal to each other. And if you don't know that, you might want to write that down. A proportion is two fractions that are equal. Okay, that's all. Notice there's no +9, there's no extra stuff. It's just two fractions. That's when you can cross multiply. Okay, so we get 16x is equal to 8 times x minus 3. Now all you have to do is distribute. Again, when I'm doing these problems, you guys should really stop the tape and try to figure them out if you are not sure if you know what you're doing. It's good to go through the process of thinking, of problem solving. I can't give you that time on the tape, but you can give yourself that time if you pause it. Negative 24, bring down the negative. Don't forget that negative. I subtracted 8 from both sides, you guys. Now I'm going to divide by 8, and I get negative 3. That's x. Okay? Okay, next. Now we're going to do word problems. Again, words matter. You're just looking for the words that are going to describe what's on the top and what's on the bottom of this fraction. Okay? What's on the top, what's on the bottom. Okay, so we are going to try to watch. Ready? A certain medicine is given in an amount proportional. That's important just to know that they're going to give you a proportion. Suppose a patient weighing 195 pounds requires 212 milligrams of medicine. Okay, so they don't actually give you the word two, but here's what they're giving. They're telling you that a patient weighs 100. Oops, I forgot to undo this. Hang on, my bad. They're telling you that a patient weighs 159 pounds, 212 milligrams. Okay, I'm surprised they give you pounds, you guys. They always do kilograms. They usually convert your weight at the doctor to kilograms in order to do these conversions. Anyway, it says, what is the amount of medicine required by a patient weighing 129 pounds? So here's the thing. They're actually giving it to you in mixed up form only because they want to make sure you know what you're doing. So here's what you have to decide. You have to decide what goes on the top, what goes on the bottom. Okay? I'm going to show you both ways, but I'm going to first put it this way. I'm going to put weight over milligrams medicine. That's how I'm going to arrange this. What that means is that when I set it equal, it has to have the same on the other side. You can't switch it up. You can't put milligrams on the top and weight here. Okay, so watch. It says a patient weighing 159 pounds. So they're going to give you one of the fractions. So that's 159 to 212 milligrams medicine. equals. Now it says, what is the amount of medicine? So where's my X, you guys? Look, milligrams of medicine is on the bottom. X goes there. 129 pounds. See? Pounds on the top. I don't know if you guys know that. LBS is pounds. Okay, pounds on the top, weight on the bottom. Now you can solve with cross multiplication. Okay? I'm actually not going to solve this for you guys. This is mostly about setting it up, and I'm going to assume by this point in your work you will know how to cross multiply. Here's what I do want to show you. What if you decided to do medicine over pounds? Then you would do medicine, we don't know what it is, over pounds. Get it? And then look, it's the same thing. In this case, we get 159x. Just write it here. 159x equals 212 times 129, whatever that is. 212. I didn't do that right. 212 times 129. Obviously, you would just do that in your calculator. But look here. You guys, it's the same. Look, you get 159x equals 212 times 129. So the main thing, it's not about which one goes on the top, which one goes on the bottom. It's mostly about making sure that the samey-sames go in the samey-same position. Okay? So you can try the next one if you want. Okay, so I'm going to do it now. Okay, it says, Diane, look, I'm in a problem. 348 miles, 15 gallons of gas. So in other words, it's 348 to 15. At this rate, how many gallons? That's your X, okay? When they say how many, that means that's your variable. You don't know what it is. To drive 232 miles. So we are going to put, I don't care, whatever you want to put, miles to gas. Let's put miles to gas. Okay, so we have 348 to 15 is equal to, what is it, miles to 32 to X. And then you just simply cross multiply to solve. Okay? All right. This actually can be written a couple different ways, but in effort not to confuse you, I won't do that. Okay, it's easiest this way, in my opinion. In my humble opinion. Okay, here we go. Last one for this particular set of notes. This is, again, real world problem, but problem type 2. Okay, each marble bag sold by Amanda's Marble Company contains 4 purple for every 5 blue. So that is a 4 to 5 ratio. That is purple over blue. I recommend writing if you need to, you guys. Sometimes it's just helpful. If a bag has 24 purple marbles, because purple's on the top, how many blue? There you go. And then you cross multiply. 5 times 24 is 120, I think. Yeah. All right, and then you just keep going. X equals 30. Okay, but okay, now on these problems, sometimes they ask you for something else. So no, they're just saying how many blue. Never mind, it's not the tricky ones. All right, let's try this one. Each marble bag, wait, I get the same problem. Shh, shh. I'm gonna unlock it. Ready? Here goes unlock. I'm just gonna erase this one. Okay, so let me go back. Come on down again. Okay, I think that's it as far as that goes. I don't know that we need another example. Okay, the main thing is to make sure that if they tell you that if they're comparing two things, you want to make sure that it's the same on the top on both sides of the proportion. Okay, proportion. A over B equals C over D. That is a proportion. All right, I'm going to go ahead and stop that.